Hello students, welcome to IIT Foundation. Myself Shivashankar. So I am going to continue the last exercise numericals. Okay, in the last class we have completed up to 7 numericals. We will continue now remaining numericals. So eighth one, if 3 particles of masses 2 kg, 1 kg and 3 kg are placed at corners of an equilateral triangle of perimeter 3 meter, then the distance of center of mass of particles from 1 kg which is at the origin is. Okay. So there are 3 particles of masses are placed at the vertices of the equilateral triangle of a perimeter 6 meters is given there. Okay. So I will show in the diagram. Eighth solution. An equilateral triangle of perimeter 6 meters. Perimeter 6 meters means each side, let us consider this A, B and C. So this will become 2 meters. Each side will be 2 meters. Each side will be 2 meters. And 3 particles are placed 1 kg, 2 kg and 3 kg. They have said here 1 kg mass which is at origin. 1 kg mass which is at origin. So here at this point 1 kg mass is there at the origin and this is on the x-axis, 2 kg mass on the x-axis. Let us consider here 1 kg mass. So at the origin 1 kg mass is there and at this point 2 kg mass. So here 2 kg mass is there. Now here 3 kg mass is there at point A. At point A 3 kg mass and here they have given there 1 kg mass should be at the origin, okay, and 2 kg mass should be on the x-axis and remaining will be in the xy plane. That is the 3 kg mass of the body. Okay. So now we should write the coordinates of this triangle with this all the 3 particles. So we can say here coordinates for this 1 kg mass of the particle is 0, 0, we can write 0, 0, and for this particle, for the second particle, it is at a distance from the origin 2 meters. So now the x coordinate will become 2 meters and y coordinate will be 0 because it is there on the y axis. The x coordinates, so coordinates of 1 kg mass is 0, 0 and coordinates of this point particle C are means 2 kg mass of the body is at a distance from the origin 2 meters. So x coordinate will be 2 meters and y coordinate it is there on the x axis. So y coordinate will be 0. Now we should find out this one, coordinates of this particle. So how to find out? We can find out from here, no? So this is a, let us consider this is a x height, and if this is a this is a 2 meters and this will become 1 meter. Now let us consider this is a point D. So let us consider this point here, it is D. Now this is a side. Okay, this is a 1 meter distance. Now BD, this is a 1 meter. And we need to find out this one. So by using the Pythagoras theorem, we can find out the distance there. Okay. So here from the triangle here, from triangle BAD, from triangle BAD, from the triangle BAD, x value what will get there? X value what we have to find out? So here that is 2 square is equals to Pythagoras theorem we should apply in this triangle, in the right angle triangle. 2 square is equals to 1 square plus this is a 1 square BD square, no? Otherwise I will write here the formula. See, if you apply the Pythagoras theorem, what will happen there here? BA square is equals to BD square plus AD square. So now BA square is nothing but 2 square plus is equals to here BD is nothing but 1 meter, no? This is a 1 meter whole square 1 square plus AD is what there? X. So x square. Now from that we should find out x. How can you find out? So it will become 4 and that is equals to 1 plus x square. So from this, if you send 1 that side, it will become 4 minus 1. So here we'll get there x is equals to square root of 4 minus 1 is 3 now. So x value will get here 3. So this value we got here 3, root 3, sorry. X square is equal to 3 and x value we want there. If you send that square that side, it will become root. So root 3 we get here. Now the x coordinate is from the origin. How much distance this particle is at 1 meter. X coordinate is 1 meter and y coordinate is 3 meters. See now here we got all the coordinates. So coordinates of 1 kg mass is 0, 0, coordinates of 2 kg mass is 2, 0 and coordinates of this 3 kg mass is 1, 3, root 3 meters. Okay. So now we can find out center of mass of the center of mass of these 3 particles. We can find out somewhere it will be here somewhere. It will be somewhere there. So the coordinates of the center of mass we can find out there, because here x coordinate, y coordinate is there. Here also x coordinate, y coordinate is there. Here x coordinate, y coordinate is there. Okay. So we know the formula xcm. Now coordinates of the center of mass we'll see. So up to here you write down there, in the next page we'll do. Okay. In the next page you see here. Coordinates of center of mass, coordinates of center of mass. So that is xcm comma ycm. So xcm formula we know, xcm is equals to what can we write there, m1 x1 plus m2 x2 plus m3 x3 divided by, so m1 plus m2 plus m3, m1 plus m2 plus m3. Okay, that is the formula there. Now here we should write here m1 value how much there? Here you see there m1 value is this, you write on here, this is a m1 and this is a m2 and this will be the m3. So this is equal to m3. M3 is this one, 3 kg. And x1, so here this is nothing but here x1 comma y1 and this is x2 comma y2 and this is x3 comma y3. Okay. So now we have the x1 value 0 and x2 value is 2 and x3 value is 1. X3 value is 1. M1 value is 1 kg, M2 value is 2 kg and M3 value is 3 kg. Okay. So now here we can write substitute here 1 kg 1 into, so it is 0 plus 2 kg into 2, x2 is 2 plus here M3 is how much there, 3 kg into x3 value how much we got there, 1. So divided by 1 plus 2 plus 3. 1 plus 2 plus 3. So how much we get here? This is a 4 plus 3 divided by 6. So we will get there 7 by 6. 7 by 6 will get there. 7 by 6. So therefore, we got from here we got xcm. xcm is equals to 7 by 6. 7 by 6 we got there. Okay, 7 by 6 meters. Now we should find out ycm. ycm formula we know, that is m1 y1 plus m2 y2 plus m3 y3 whole divided by m1 plus m2 plus m3. m1 plus m2 plus m3. Okay. So now m1 value we know. m1 value is how much? 1 kg and y1 value is 0 no. Here we can see that here. So y1 value will be 0 and y2 value will be 0 and y3 value root 3 we got. y3 value will be, so y1, y2 will be 0, y3 value only is there. Okay. So now see here. So this is a 2 kg into y2 value is also 0 plus here this is a 3 kg into root 3. Y3 value is root 3 divided by here 1 plus 2 plus 3. 1 plus 2 plus 3. See, here these two will become 0. This value and this value. Only the remaining is here. Remaining is how much there? 3 here. Remaining is 3 into root 3 divided by 6. So 6, 3 1 is 3, 3 is sorry 3 2 is 3 1 is 3 2 is. So we will get here the value is root 3 by 2 meters. So therefore here YCM, we got YCM is equals to root 3 by 2 meters. Root 3 by 2 meters. So up to here you write down there. So therefore here we got coordinates of center of mass we got there. This we got here, that we got now means XCM comma YCM we got coordinates of this, that is 7 by 6 comma root 3 by 2, root 3 by 2, 7 by 6 comma root 3 by 2. Okay. That is the coordinates we got there. Now what they are asking in the question, they are asking in the question here what is the distance of center of mass? Somewhere suppose here you can see here in this problem. So let us consider this is the center of mass. Okay, this will be the CM, center of mass. If that is the CM, then we got the centroid. Let us consider the centroid there. Okay, if that is the CM, center of mass, then so we will get here the distance from here. Okay, and we got this coordinate of this one, coordinate of this one here. Okay, I will show in the diagram otherwise. Okay, I will show here only. Up to here it is completed now. Now see here. So where the center of mass will be situated? Center of mass will be situated like this, no? Here the center of mass will be situated there. Okay. So now the coordinates of the center of mass at the centroid will be there at the centroid. So here this value, the 7 by 6 we got. So this value 7 by 6 and this value we got here root 3 by 2. So this is a 7 by 6 we got, 7 by 6. Now this value we should find out. This is a 1 kg mass. From the 1 kg mass, how much this center of mass is there? How much the center of mass? This distance. Let us consider that is a R. How much R it is? It is an equilateral triangle now. Equilateral triangle. So from that we can say here R square is equals to 7 by 6 whole square plus root 3 by 2 whole square. Root 3 by 2 whole square we can write. So then R is equals to we can write here square root of 49 by 36 plus here 49 by 36 plus here 3 by 4 will come now. Here 3 by 4 will come there. Now simplify this one. If we simplify, how much we get there? So 36 will be the LCM. So 49 will come here plus here 9 will come now. 9 3 is a 27. This will be the 27 there. 27 means how much we get there? $76 now here. So we'll get here this is a 76 divided by 36. 76 divided by 36. $49 plus here 9 will be remain, 9 will be multiplied here 27. So 49 it is a 76 will get there. 76 how many times will go there? This we have to simplify. If we simplify, how much we get there? So this is nearly 2 2 2s are how much will get there? 2 2s are 12. 72 will get, no? 2 2s will get here. So means 76 by 36. So 1s are here, 2s are. 72 will be there. 72 means 4 will be remain there. 4. So 40 means 1 1. 1 1 will be there. So this value will get here 2.11. So this, therefore, this R will be equal to, R will be approximately equal to root 2. So this approximately equal to root 2 we can add there. 2.11, no? We can make it as root 2. So the answer is how much then? Answer is root 2. Answer is root 2 meters. Answer is root 2 meters. So from this, from the origin, this distance is root 2 meters. So now the answer, correct answer is answer option option 2. Option 2 is correct. Option 2 is correct. Okay. Complete enough? From here to, you have to note down this one and finally that one. Next question. A bomb of mass small m at rest at the coordinate origin explodes into 3 equal pieces. At a certain instant, one piece is on x-axis. On the x-axis, at a distance x is equal to 40 centimeters, and another is at a x is equal to 20 centimeters, y is equal to minus 20 centimeters. The position of the third piece is, the position of the third piece we should find out there. Position of the third piece. So I will show you in the diagram. Ninth one, ninth solution. Ninth solution. A bomb explodes at rest at the coordinate origin. So let us consider here this is a coordinate system. The positive x-axis and positive y-axis. This will be the negative x-axis and this will be negative y-axis, and it is the 0, 0. And now here at this point, here a mass m has exploded. A mass m is exploded. It exploded there. One part is there at x is equal to 40 centimeters. So this x is equal to here 40 centimeters distance on the x-axis. So if it is a 40 centimeter, then the coordinates will become, here. The coordinates of this particle, it can be written as here 40, 0, 40, 0, 40, 0, the coordinates of that particle. And next one is x is equal to 20 centimeters. X is equal to 20 centimeters and y is equal to, this is a 20 centimeters, y is equal to minus 60. Let us consider this is a minus 60 centimeters. Minus 60 centimeters. So now if you draw a point like this, so here we will get a point. So now the coordinate of this particle, equal pieces, and the mass of this is m, and the mass of this is also m, and the coordinates of this we can write here, this is 20, no? 20 centimeters, x is equal to 20 centimeters from here to here. So we can write here 20, minus 60, 20, minus 60 centimeters we can write there. And third piece, the position of the third piece is, so somewhere here let us consider a position, it may be position of the somewhere here. So let us consider this one x1 comma y1, the coordinates, and here x2 comma y2 we connect, and this one, this coordinate of this particle, this is also mass m only. Here x3 comma y3 we connect there, x3 comma y3. Okay. So one particle is there here, another particle is here, another particle is here. Then center of mass of these three particles we should find out there. Center of mass of the three particles. Okay. We know that if the bomb is exploded, the center of mass of the position of the path of the center of mass will not be disturbed there. The position of the center of mass will not be disturbed because all are equal in pieces. So then center of mass will be at the origin only. So center of mass will be here only, xcm comma ycm we can write. So this is only the center of mass here. Center of mass will not go. Position of the center of mass does not change there. Okay. So when all equal pieces are exploded into the pieces, then here we can write there xcm can be, xcm is equals to we can write xcm is equals to, so m1 x1 plus m2 x2 plus m3 x3 whole divided by m1 plus m2 plus m3, m1 plus m2 plus m3. Okay. So now here write down there. So mass is same, m only, and x1 is how much here, 40, and plus m2 is m, and x is 20 centimeters, x2 is 20 centimeter, and x3. So plus m into x3 divided by here m plus m, 3m will get here, 3m. And from this we can write here x is equal to, this is a 0. So from that we can write, what can we get here? What we will get from this? I will write in the next page. So from there we can write here, see here 40m plus 20m plus m into x3. So 40m plus 20m plus here we will get there m into x3 is equal to 0. Here 3m is there, 3m if you send other side it will become 0 there. So in all there m is there, we can cancel this one. So what will get here, this 40 plus remaining is 40 plus 20. So 40 plus 20 plus x3 will get, so that is equal to 0. Then here we can write 60 plus x3 is equal to 0. Therefore x3 will get here, x3 is equals to minus 60 centimeters. So x3 value we got minus 60 centimeters. Now ycm, so we should find out here ycm. So ycm can be written as, ycm is equals to ycm m1 y1 plus m2 y2 m3 y3 divided by m1 plus m2 plus m3. Okay. So masses are same there, and y2, y1, y2, y3. So y1, y2, y3. For that I will see here, y1 is 0 and y2 is minus 60, y3 we have to find out there. Okay. So now see there. So m1 is m only and y1 is how much? y1 is 0, it is there on the x-axis, plus this is m into minus 60 plus m into y3, So whole divided by, we can add 3 now. So again from this, from here ycm is 0 there, okay. The center of mass will not be changed, so we can equate it to here 0. It can be equated to 0. So if it is equated, then what will get here, this is a minus 60m plus y3m is equal to 0, and this also same here, mass is same, we can cancel it there. So from this we can get it there, y is equals to y is equals to, if we send this other side, it will become plus 60 centimeters. So now therefore, we can write here x3 comma y3 is equals to, how much we get here? So minus 60 comma plus 60 centimeters. Minus 60 comma plus 60 centimeters. So the correct option is here minus 60 plus 60. So therefore the answer is option 3 is correct. Answer option 3 is correct. Next problem. Find the position of center of mass of the uniform lamina as shown in the figure. See, I will draw the figure here. So 10th one. Is there. Find the position of center of mass of uniform lamina shown in figure. So here it is given a circular lamina, here a circular is there, a circle, and this has a center here. Again here one more circle, this is a circle there of radius. So this is a radius of the circle, radius of this circle, here the center O, and for this center here there. Okay. Now this is a A. Okay. For the bigger, now for this and it is there, this is on the x-axis. Okay. This is x-axis and this will be the y-axis. So here this part has removed there. If any part of this a circle of a by 2, so this is here for we can write here capital R1. So capital R is the center radius of the bigger circle. So that is we can write here A. So and R, smaller can be written as the radius of the smaller circle. So this is the radius of the smaller circle, we can write here A by 2. Now area of the bigger, we can write here A1, that is equals to pi R square, no? Pi R square. So means here pi A square we can write there, pi A square, and A2 will be the area of the circle, that is this one, no? Here we can write there pi into small r square we can write. So from this we can write here pi into a by 2 whole square. A by 2 whole square means we will get there pi into a square by 4 will get there, a square by 4. A square by 4. A square by 4. So now here, so for the this one, for the bigger sphere, the center of mass of the heavier radius R can be written as 0, 0, no, because it is at origin, and the center of mass of the smaller circle, so that we should find out there. So from the origin it is at a distance. At a distance how much there? Pi by 2, no? It is at a distance of a by 2 radius. This is center here, a by 2 radius. Now we know that the formula, if a certain part of the mass or area has removed from the whole mass of the whole area, then we know the center of mass formula. So here we can write that xcm is equals to so a1 x1 minus a2 x2 divided by a1 minus a2 we can write, no, a1 minus a2. So here, see here we have the coordinate, and this one a comma 0 we can write, no, here. So x1 x2 is there, x1 x2 and y1 y2. No need to find out y1 because that is 0 only. So A1 we connect here, A1 how much? A1 is the area, this is, so pi A square, into x1 is at 0 only, it can be 0, okay, x1 is will be at 0 only, no, minus, here minus pi into x2 is nothing but this one, a by 2, sorry, area, A2, here A2 what can you write there? A2 will be this whole thing, no, this is a A2, so A2 is here pi into a square by 4, into a by 2, so whole divided by a1 minus a2, so a1 is how much here, a square minus a2 is what, pi into a square by 4, pi into a square by 4, so we have to simplify that equation. So pi into 0, this value will become 0, this one will be 0 here, this value will be 0, and pi into a square by 4 into a by 2, pi into a square by 4 into a by 2, okay, that we have to simplify. So we will see in the next one. So xcm is equals to, here this has become 0 there, and minus here what we got there, the previous ones here, pi a square by 4 into a by 2. So here we will get pi into a square by 4, no, a cube by here 8 will get there, a cube by 8 whole divided by, so here we will get there 4 pi a square minus pi a square by 4 will be there, okay. So now here this has to be simplified, so here 1 is and here 2 will be there, so minus pi a cube divided by 2 whole divided by, so whole divided by here 3 into pi a square, so this is the value we will get here. So from this, so pi and pi will be cancelled, a square and here a cube will be cancelled there, so remaining is a by minus a by 6, so therefore YCM as usual it is at 0 only. So now the coordinate of this one, so xcm comma YCM is equals to, here we got their xcm, so this is the value of xcm, then xcm comma YCM we can write here minus a by 6 comma 0, minus a by 6 comma 0. This is 6 here, 6, that is the answer. So correct answer is option option 2 is correct, So in the previous page, this one, what we have found here, we have found their area of the smaller circle and area of the bigger circle. Because we have the formula, this is the formula of, so this is the formula, no, for the a part of area has removed, a1 x1 minus a2 x2 divided by a1 minus a2, this formula will use there here. So we need here a1 for the smaller, for the bigger circle the radius is a, and for the smaller circle is radius is r is smaller, is equals to a by 2. This is a means smaller circle, it will become half of that, no. So we'll get here a by 2. Then a1 will get there pi r square, pi a will get there and a2 is equal to pi into small r square. Small r is nothing but a by 2 whole square. So it will become pi a square by 4 will get there. And we should find out the coordinates of this first center of the origin of the bigger circle, that is 0, 0, it is at origin. And so this one, the center of mass of this second circle, there is a smaller circle, that is at a distance of a by 2, 0. The distance of a by 2, 0. From here, from the origin, it is a by 2, 0, no? A by 2, 0. 0, why it is 0? Because it is there on the y axis. So now in this formula, we have substituted these all the values. A1, A2 value substituted and x1, x2 value substituted. x1 is what there here? 0. y2, x1, 0 and x2 is a by 2. That value is substituted here. So simplify, we have simplified here. We got this answer. So that is a minus a by 6. Minus a by 6. Now level 2 problems. Level 2 problems will do there. So up to here we have completed J means level 1 we have completed in exercise 1. So in the next class we will see there from 11, 12, 13 J means level 2 problems will complete in the next class. Okay. Thank you.